Good morning. Welcome to Computer Science 311, and we start a new chapter today. This is chapter 4. Chapter 4 has to do with what are called stacks and queues. And actually, we're going to talk about stacks and queues again in chapter 5. What we're going to be talking about in this chapter are what are called static implementations. So the first question is, what does this word static mean? And if something is not static, what is it? Well, if it's not static, it's dynamic. Static versus dynamic. And the difference here between these two words is that when something is static, that means we allocate the memory ahead of time. And dynamic means that we allocate the memory as we need it while the program is running. So again, that might seem kind of fuzzy right now. Another way to think about this for the moment is an easy way to think about this is that static means we're using arrays. And over here, we're going to be using this in Java. You use that word new and you allocate an object. You're going to say new, and I'm going to say object here. And we're going to look at these much closer in chapter 5, but dynamic memory allocation is like when you're looking at things like linked lists and trees and other data structures. But it turns out we're going to be looking at these things called stacks and queues, and you can implement stacks and queues either statically or dynamically. So we're going to be talking about static implementations in chapter 4, which means we're going to be using an array. So let us consider what is a stack. And I think that there are folks here that probably know what stacks are already. First of all, a stack is a LIFO data structure. And LIFO, that means last in, first out. And I guess the way that I think of stacks is I think of when I go to the cafeteria and you have to grab a plate. And when you sit there or when you go up online and you can see that there's a thing there, and here's a plate, and here's a plate, and you'll have to pardon my artistry here. I know it's pretty bad. And finally there's a plate here on top. And basically what you do is when you come in, you pick this plate up. And this plate that you're picking up was actually the last one that somebody else put down there. And when you pick something off the stack, that's called popping the stack. And when you place something onto the stack, that's what's called a push. So these are the two verbs that people associate with stacks. And we're going to create one of these things. So besides implementing push and pop, we need to create these things. So we're going to need a constructor. And we're going to need two other things. We're going to need to know, is the stack empty? And the other one we want to know is the stack full? Remember, we said that this is going to be a static implementation, which means we're going to use an array. And we know that arrays are of finite size. So one of the things that we have to worry about is the thing full? In other words, we can't push something onto a full stack. Likewise, we can't remove something or pop something from an empty stack. So the idea of a stack is that we're going to have some array over here. And we're going to have a variable over here. And we're going to call this the stack pointer. And initially, this is going to have the number 0 in it. And I might come over here and I might have a stack called myStack. And I might say something like myStack.push. And I might say push 83. So first of all, in this particular example, we're talking about a stack of integers. And the way that this would work is I would come over here and I would see that the stack pointer is 0. So I would put the number 83 over here. And then what I would do is I would change the value of the stack pointer to 1. And now I might come over here and I might say something like myStack.push 3. And again, what I would do is I would come over here and I'd see the value of the stack pointer is 1. So I'd come over here to slot number 1 and I'd put a 3 in here. And what I would do is I would change the stack pointer now to 2. So the first thing that we can see here is this operation called push. And let me move things around here to give ourselves some room here. So first of all, we can see that push, and I'm going to say int val, and we can see that basically what we do in push is we let, and we need to have something over here, so we'll just call this thing data. Okay, so what we need to do is we need to say that data of the stack pointer gets assigned val, and then what we need to do is we need to increment the stack pointer. So that's basically push, and we'll get to writing the actual code for that in a moment. Now, popping the stack, if I were to come over here and say something like x is equal to myStack dot pop. Okay, what would happen over here is, as you can see, the first thing that we would do is we would decrement the stack pointer. I'm going to come over there and decrement it, and it's 1. And now I'm going to return the value that is at that position. So at this point over here, x gets assigned the value 3. Now notice the stack pointer is 1 now. Now the 3 didn't get erased, but what's going to happen is it will get overwritten the next time that I push a value onto the stack. So we can talk about how pop works. So pop, what we're first going to do is we're going to decrement the stack pointer. So we could go set like that, and then we could say return data of stack pointer. Pretty easy. We could have this Boolean thing called isEmpty. And that's pretty simple. There we would just return stack pointer equals 0. And I think you could think about this. This is not hard either. Is full. And here we would just return stack pointer equal to remember, data is an array. Data.length, the length of the array. Okay? And this is really the whole thing right here for creating a stack pointer. So if we wanted to have the actual code, so we might have something like public class stack. And we'd come over here and we'd have public stack. In the 0 parameter case, and we might come over here and we might say data is equal to new int 10 and stack pointer equals 0. 0 parameter stack. Okay, so there are constructors. We could have a public void push int x. And let's see, we say data of stack pointer is equal to the value, and then stack pointer plus plus. Well, let's do something interesting here just to see what you all think about this. I'm going to say data of stack pointer plus plus equals x. Do that all in one line. What do you think about that? And then there is pop. Now, because I'm returning an integer, so this would be a public int pop. And again, I'm just having some fun here and giving you something to think about. I'm going to say return, and I'm going to come over here, and I'm going to say data of, and I'm going to decrement like that. One line. Notice over here I used a post increment. Over here I used a pre-decrement. And I leave it to you folks to study this a little bit. Convince yourself that what I've written here is doing the same thing as what I've written over here for these two procedures right here. All right. So then I come over here and I have, I'm going to try and squeeze this all on one screen. Public Boolean is empty. And I'm going to come over here and say return stack pointer equals 0. Okay, and I'm going to have to make a little room up here. I'm going to have public Boolean is full. And I'm going to come in here and say return stack pointer equal, and this is what I get for trying to put it all on one screen. But I'm going to say data dot length. Do I put parentheses here or not? And the answer is no. Parentheses would be referring to a string. Without parentheses, it's a property of arrays. So I'm going to come over here and do this and do that. And I'm going to close that up. And then I would be closing up. And I'm just going to say end stack. Okay. So with a declaration like this, I could now come over here and do some code like the following. I could say my stack is equal to new stack. And how big do I want to make it? Let's make it 20. And I could come over here and I could say my stack dot push 10. I could say my stack dot push 20. My stack dot push 15. And then I could do something kind of clever here. I could say something like while, and then come in here and say not my stack dot empty is empty. My mistake. I could come over here and say system.out.println mystack.pop. And if I were to say to you, what is the output of this? Of course, it would pop the stack until it's empty. It would pop a 15, and then it would pop a 20, and then it would pop a 10, and then the loop would terminate. Okay, that's it for stacks. All right, so we finished with stacks, and now we're going to implement a static queue. And you may recall in class I asked you, what does the word queue mean? And queue actually comes from the French. And it means tail. Okay. Anyway, so a queue is an example of a FIFO data structure. FIFO meaning first in, first out. And what a queue would correspond to, you should think about you're waiting online at the cash register at the store. There were a bunch of you lined up. Here's the cash register here. And the next person to go to the cash register would be this person, then it would be this person, then it would be this person. Somebody comes along, they go to the end of the line. So the people in front of them are going to go first. So a little thought about how this might work in a static implementation. And I'm asking you to watch because we may have to alter this. So let's suppose, again, we have data over here. 0, 1, 2, 3, 4. And the idea here is we're actually going to need two variables here. We're going to need a variable that we're going to call front. And we're going to need a variable called back. And you might think that initially we would have both of these things set to 0. And then you might think that I might do something like the following. I might say my queue dot push 100. And remember, we said that when you enter the queue, you enter at the back of the queue. So I'm going to use this number here to tell me where to put this. So I'm going to come over here and I'm going to put a 100 here. And then what I'm going to do is I'm going to change the value of this to 1. And I make that a 1. So now I come over here and I say my queue.push 53. And again, I'm going to use this number 1 that says come over here and make this a 53. And now what I'm going to do is I'm going to come over here and I will make that a 2. So everything seems fine so far. And again, if I were to come over here, for example, and I say let x equal my queue.pop, we could imagine that what would come over here is I would come over here and I would look at data up front. And so x would get the value 100. And then what I would do is the front of the queue would no longer be at 0. It would be at 1. Okay, so far everything seems fine. But there are a couple of features that I want to do here. So remember what's happened at this point. This guy's no longer in the queue. This is now the front. This is now the back. So you can see that basically what's happening is back kind of marches its way down the array, and front also marches its way down the array. But what happens is what I want to do is I want the thing to wrap around. In other words, maybe I'm in the case where maybe the array looks like this. Maybe front is referencing that, so that would be 0, 1, 2, 3, 4. So maybe front has the value 3 in it. And maybe back has the value 4 in it. And I want to do a push. So what I would like back to do is I would like back to wrap around and come back to 0. Okay, so what I'm actually doing here is this is sometimes what's referred to as a circular queue. And the mathematics of this is actually pretty simple. Okay, this is an array that has 5 elements in it. So when I increment back, instead of just saying back is equal to back plus 1, okay, because remember what that's going to do, well, saying back is equal to back plus 1 is fine until back gets up to the number 4. What I want to do is I want to say back is equal to back plus 1 mod 5. So think about that. When back is 4, 4 plus 1 is 5, and 5 mod 5, the remainder, okay, of 5 when I divide it by 5 would take it back to 0. Likewise, I want to do the same thing when I increment front. I want to say front is equal to front plus 1 like that. Okay, so in other words, when I do my pushes and pops, I want to do this. Okay, but now I have another problem. Initially, we thought an empty queue was front equal back equals 0. And I should make these like that. And upon further reflection, it doesn't necessarily have to be at 0. It could be anywhere in there. So we think that the empty queue is when front is equal to back. But now I have another question. When is it full? I don't know. Let's think about it. So here's the empty queue. And I've got front and I've got back. And when it's empty, they both look like that. Now I come in there and I put a number in. Let me get my eraser handy because I'm going to need to be updating things. So I come in there and I put 100 into the queue. And I put 100 into the queue, and now back changes. All right, and now back is there. And now I come in and I put some number here. I push. And now back changes again, and now back is there. And I put some number in, and now I increment back again. Back is equal to back plus 1 mod 5. And now back is over to here. And now I put some number in, and I increment back again. And now back is over there. And now here's the part that's scary. Okay, we still have a slot left in here. So I go, all right, I'm going to push another value in there. And I push 70. And now I say back is equal to back plus 1 mod 5. And guess what? Back is now pointing again at the same place as front. The problem we have with this implementation is I can't distinguish back from front. Okay, so how do I fix this? I have two ways of fixing it. One way of fixing it is I can say, okay, when I'm in this situation, when front is pointing there and back is pointing there, then it's full. Now, of course, what this is doing, notice I'm calling it full even though this space is empty. In other words, we could say full is equal to back plus 1 mod 5 is equal to front. That's one way of doing it. But the problem with doing that is of course, we waste a space. The other way that we could do this is we could have a counter. We could just say count. If count is equal to, well, no, that's not going to work either. If count is equal to 5, we'll have to define a variable for this. Then that would be full. And that would let us have the situation where we could use this space over here. So with that information in mind, we're going to come over here and we're going to implement our queue. And I'm going to say public class queue, and I'm going to say 0 parameter constructor, you do it. Okay, but I'm going to come over here and I'm going to say that there is going to be int data is going to be int front and back. There's going to be int count, and I'm going to call it SZ. Okay, and basically if we come over here and we have public and we have to have a constructor, int, and I'm going to call it size. I'm going to come over here and I'm going to say let data equal new int size. I'm going to come over here and I'm going to say let SZ equal size. I'm going to come over here and say let count equal 0. And then I'm going to say let front equal 0. And I'm going to say let back equal 0. Okay. I'm going to try and keep this up here so we can see this all on the screen. So first of all, I can do public boolean is empty. And that's easy. Return count equal 0. Public boolean is full. Again, that's easy. Return count equal size. That's when it's full. And now we do a couple of other things here. So I would do public void insert int val. So now this is not hard. So we come over here and I'm going to say let data of back equal val. And then I'm going to say let back equal back plus 1 mod size. Everybody get it? And to do I'm sorry, we should actually call this, all right, where is this should actually be called push. And then we would have public int pop, and I'm going to come over here and I'm going to say int return value is equal to data of front is equal to front plus 1 mod SZ, and then I return front. Okay? And I think that's the end of the queue. What you should do is you should study this code, type it in, run a sample program to see if it works, and let me know if there are any errors.